Hello everyone, today will be a final session on our project, and today I will go through the code and I will explain it, and at the end we will do a small simulation on WalkV. Okay, to begin with, the first line itself says hash include liquid crystal underscore I2C. Here what we are doing is that we are just importing the two libraries of the display, LCD display, and our sensor HC SR04. Okay, before that we need to ensure that the libraries are already installed in our Arduino IDE, and if not we can do that, like go to manage libraries and just search liquid and then scroll down and you will see liquid crystal I2C by Frank, this one. Okay, exactly this one. You have to install it. The second one is HCSR04. Okay, do the same for that also. HCSR04. Hit enter. And this is this is the one. HCSR04 ultrasonic sensor by GameGen. Okay, just install that. Now our libraries are installed, and now we'll go to the code and see how it works. Here we are creating an object for both LCD and the sensor. Okay, and this is the object for our class HCSR04. Okay, now we can consider this as an object and this is the class. By doing like this, we can use all the properties. We'll be having access to all the properties that are defined in this particular class. In layman's language, you can consider it as a parent. This as the parent, the class as the parent, and this as the child. Okay, the object as a child. Okay, when we do it like this, okay, we will be having all the access. This object HCC. We having access to all functionalities, properties, and the variables that are defined in this thing. Okay, and here we are passing the trigger pin and the echo pin, and what trigger pin and what does those pins do were covered in the previous videos. Okay, if you have not gone through it, please go through it. Okay, and we're doing the same thing over here. Okay, and here this is the 16:2 display we are using, right? So we mentioned here 16:2, and this is the address of the I2C communication. Okay, you will be the LCD display will be having by default this address as its I2C communication address. Okay. Then we define a variable reset distance. Okay, and its type would be float. And here we enter into a code. This is the setup section and this is the loop section. In setup, we'll be initializing our devices. Okay, here we'll be initializing our LCD, and we'll be turning on the backlight of our LCD. And we come on to our code. This is actually this is the part that actually repeats forever. Okay, this is the code actually. The first line is the distance. Okay, this line would give the distance from our ultrasonic sensor. This function gives the distance from the ultrasonic sensor and assign it to this variable distance. And here we're just defining the height of the jar. Okay, it's given 100 here. You can change this thing as per the height of the jar you will be using. Okay, here this is an if statement. Okay, if the distance, okay, the distance that is measured by our sensor, if it is below 100, okay, it actually measures below 100, right? Because it will be placed at the top of your it will be at the neck of your jar. Okay, so the maximum distance that the sensor will be measuring is 100. Okay, and if that distance is you can just give it as 101. Okay, and if it is below this one below this 101, okay, you will be executing all these statements mentioned here. The first one will be calculating. Okay, actually the sensor is placed at the top of the lid, you can say. Okay, So whatever it is measuring, it will be actually the depth of the water. And if you want to convert to the height of the water, you can use this expression. It's actually the height of the jar minus distance. This gives you the height of the water in that particular jar. Okay, and that height will be assigned to this distance, to this variable reset distance. Okay, and next what is coming is that LC.clear. Okay, right, this function, this thing, the header file, this has everything, all our functions, everything defined it already, so we just need to use it, that's all. Okay, yeah, and this is the child, this is the object, and with the help of that object we are accessing that particular function. Okay, with the help of that object, using that object, we are accessing the functions that were already defined in this header file. That's what's happening here. Okay, using this object, LCD object, we are accessing the clear function. Okay, this, what does it do is that it will clear the LCD display, and here set cursor. This is the first one is the column, second one is the row. So the cursor will be set to the first row, first column. Okay, and a height of the water will be printed up there. Okay, and the next one is set cursor 0 1. This is the first column, second row. Okay, so what's happening is that it will the height, this string will be, this string will be printed on the first row, and the actual height that we calculated over here, that we found out over here, will be printed on the second row. This is what's happening there. Okay, yeah, this the cursor will be set to the second row, first column, and our actual height of the water would be printed over there. Okay, and we're calling a 150 millisecond delay here, and this all this would be iterated, will be repeated after every 150 millisecond in a loop. And that's all about the code. Okay, and we'll move on to our simulation on Walkvi. Walkvi is a online, free, simple online simulation tool that we can use. Okay, fine. Yeah, this is our code. Actually, this is our code. It's the same code actually. Okay, and this is the circuit that we just implemented on Walkvi. We will run it. I will SCC 12,10. 12 trigger pin goes to pin number 12 of Arduino. That is where going to 12, and echo pin goes to 10. It is going to 10, and and the VCC is going to the 5 volt supply of Arduino, and the ground pin is going to the ground of Arduino. Same here. This is an LCD display with I2C module. Okay, so this module will be already present, already mounted at the back of this LCD display. It will be having 4 pins, ground, VCC, SDA, and SCL. This is the ground, this is the VCC, this is the data pin, this is the clock pin. Okay, and this pin is this is where all the data is transmitted through this line, and through here the clock will be sent in order to synchronize everything that's happening within the LCD display and the Arduino. Actually SDA goes to pin A4, analog pin 4 A4, and SCL goes to A5, and ground and VCC has same as our sensor. And that's all about the circuit. And when we run it, the height of the water is displayed on the first line, first row, and the actual height of the water would be what we calculated, the result of this calculation would be printed over here. Okay, we are just suppose we can just vary the distance. Look how the height of the water is changing. Actually this sensor is measuring the distance between the neck of the jar and the top level of the water. Okay, we are converting it into the height using this expression here. Okay, this is the distance. Okay, this is the distance between the neck of the jar and the surface of the water. Okay, suppose it's 50 centimeter, so the bucket would be like or the jar would be like half filled. Okay, so this is what is printed on our LCD display. Suppose it is like fully filled. Okay, look, it is fully filled. Height of the water would be 97. Yeah, almost 97, 98, 99. Okay, fine. And that's all about the code here. I mean, yeah, that's all about the simulation. Fine. Yeah, and that's it. Thank you.